Good afternoon. I am Mr. Ish. You are joining me for another video here. We're looking at tests of functions, or you can say function tests. We know functions are abbreviated as f of x, but this really means you're looking at something which is y, and then you end up having some sort of expression over here. What exactly is a function? You know, it's a rule or a correspondence between two sets of elements. Set A can generally be your domain or your inputs, and set B can be your range or your outputs, and the function serves as an intermediary between the two. An equation is a function for a number of reasons, and we're not going to get too heavy here into pre-calculus because our purpose is standardized test preparation. A good evaluation for expression to meet the definition of a function is if it meets the vertical line test. And you know what? We can abbreviate that in a very good way, and we can call that VLT, a vertical line test. If you have a certain number of coordinates, you know, coordinate pairs, an x and y coordinate pair over here, if you have such values popping up as a single x value is generating multiple y values, in this case one single x value is giving rise to a plus and a minus y, then you know the vertical line test will fail, and that expression into which this coordinate falls into will not be a function. What could be a good example of something like that? How about a graph which looks something like this? At this specific x value, you look up, you have a positive y in terms of the output, and at that specific value you look down and you look across, you have a minus y. So here you have an x comma plus and minus y, and if you were to draw a vertical line through this function, it would cross at more than one point, and therefore it would fail the vertical line test. Very simply, the vertical line test succeeds and an expression is a function if that vertical line crosses a function or a curve at only one point. When it crosses at more than one point, it fails the vertical line test, and that expression or equation is no longer a function. So let's look at two test related questions with regards to the subject we have in front of us. For the first question, we have to identify which of these represents a function, which one does not. Remember the vertical line test. If a vertical line crosses a curve at more than one point, it fails the test, and then that equation is not a function. Let the equation over here just be f of x, let this equation here just be g of x. It doesn't have to be accurate by any means, it's just hypothetical. If you look at a single point over here and you draw a vertical line, it only crosses this curve at one point, therefore this must be an equation of a function, and it very well is. It's a quadratic parabola. These quadratic parabolas are functions. Even if supposedly you look at a specific point over here and you have a horizontal line crossing at more than one point, it doesn't matter, it's still a function. In this instance, you're seeing something like plus and minus x giving rise to the same y value. That's fine. That's very well allowed. You can have multiple x values give rise to the same y value and it would still be a function, but you can have a single x value give rise to multiple y values, as would be in this case, where if you drew a vertical line, you would have intersection at more than one point, so therefore this right here is not a function. In this instance right over here, you would have a coordinate which would look like minus x plus and minus y. You see this minus x, here's my origin, here's my minus x, here would be a positive y value, here would be a minus y value. So in this instance, a single x value is giving rise to two y values, and that fails the vertical line test. So this is not a function, but this right here is a function. Alright, we have to evaluate. This right here is, let's call that function f, we'll call this equation g. Which of these represents a function, which one does not? Again, just draw a vertical line. If a vertical line crosses at more than one point, it fails the vertical line test, and it is no longer a function. But in each of these instances, even down over here, a vertical line is crossing at one point only, so it passes the vertical line test. And this right here, which represents a natural log x graph, a natural log curve, is indeed a function. When we're looking at something like this, we're looking at what appears to be a cosine function, and if you were to draw multiple vertical lines, they would always cross at only one point, and it would always be a function no matter what. And this tells you that this right here is indeed another function. This right here is a cosine x. Generally, all trigonometric functions are functions, all logarithmic functions are functions. True functions, they always succeed the vertical line test. Likewise, exponential functions also succeed the vertical line test. They are indeed true functions. So these again are both examples of good functions. They pass the vertical line test. So with that, let's end this video. I hope you enjoyed this video. Thank you for watching. Stay tuned. Have a nice day.